Hi, and welcome to my presentation on file table and semantic search, a new functionality in SQL Server 2012. My name is Michael Rees. I'm a program manager in the SQL Server Engine team. SQL Server 2012 is adding lots of rich capabilities and services to manage unstructured data in the context of your relational database. We are improving our scale to be able to store and search 100 to 500 million documents. We are improving your ability to access unstructured data stored inside your database from all your applications. And we are adding capabilities that give you rich insight into the information that you store inside your unstructured documents to enable you to make better decisions across these collections of documents. Let me show you an example by showing you how we actually give you the ability to manage your documents in the context of SQL Server 2012. Let me show you now the demo. I'm connected to SQL Server 2012 here with Management Studio. As a first step, let me create you a database called SQL Server Articles that is exposing a file stream file group which I will be using to store my documents in. Please note that I give two settings here with the file stream. The first one is non-transacted access equals full, which is a new setting that I use for making it Win32 accessible. And I also give the database a name called SQL Server Space Articles that I will be using in the context of my UNC path names. So now let's use the database, and let's create a table that I will be using to store my documents. This table is called Documents, and it is a specific table that we introduced in SQL Server 2012, which is called the file table. Now, as you notice, I'm not providing any specific schema for the table, because the table actually has a fixed schema that is implied by it being a file table. In addition, since it is a file table, we have additional metadata that allows us to, for example, register it within the file directory. And it also gives us the ability in Management Studio to actually open it. So I go here now into my SQL Server Articles database. I look at the tables. I see a new entry for file tables. I see the file table that I created. And now I basically right-click on it, and I say Explore File Table Directory. And that actually opens now the table as a standard shell inside Win32. So now, obviously, the table is empty. And I can show you quickly what the schema of the table looks like. So you will notice here there's a stream ID. There's a file stream that will contain the data. There are things like path locators and file type, and lots of properties that you're probably used to if you look at your file properties in Win32, such as is the file offline, is it hidden, etc. So now I can use T-SQL to do normal operations on that file table. So for example, I can insert new rows into the file table using the insert statement and create, in this case, two new directories, one called White Papers and the other one called Multimedia. So now I have created that. Let me go back to the shell and refresh. And you will notice that I now have inserted these two directories, and I can drill into, and they're currently empty. Now, of course, what I can also do is I can copy documents using standard drag and drop into my file table using my Windows shell. So I have here directory with a lot of white papers here. So let me get the SQL Server white papers, select them all, drag and drop them into my white paper folder over here. And let me also copy a couple of media files here into the multimedia directory over there. So as you notice, the copying is looking like a normal Windows file system operation, but actually the documents are now being stored inside the database. So let me just go back here and do a select star from the documents. And you will notice now that there is actually data inside the table. And you will notice that now I have all these white papers that I've loaded inside my document, inside my file table here. Now let me show you a couple of other things that we can do with it. So if I go back here just to show you that I actually have full Win32 API access, I go into my multimedia, I turn on my preview, and I go and, for example, click on the images, so you see basically what I've stored inside the database. And I can even run movies directly out of the database here. So as you can see, it's running, and if you turn on the sound, you can hear the music as well. Now, you can use T-SQL to go and actually manage the data that you have inside it as well. So you can, for example, go and make a file hidden by just setting the hidden property. And you can go and change the name. So I'm doing that for the document that is containing the heterogeneous picture. So if I go now back into my Win32 and I refresh, you will notice that now the file has changed its name and it's a hidden icon. And if I look at the property, you will notice that it is hidden indeed. But I can now also go and change it here. For example, I change it back to the original name. And if I go back into T-SQL and I do a select star, you will notice that the data has been changed back in the context of the file table as well. So now in preparation of the next demo, I'm going to create a full text catalog and a property search list that I will be talking about a little bit more in detail. And we will take that up on the next demo. So to summarize, FileTable gives you the ability to store your documents inside SQL Server, but expose it as an SMB share. In order to be able to set up your FileTable, you have the ability to set the transactional access to file data to turn it on as non-transactional, which means that it gives you the ability to do Win32 API access against the data. The T-SQL access is continuing to be fully transactional, which gives you both concurrency control and recoverability, while if you are turning non-transactional access on, it means that the Win32 access will give you the experience that you are familiar with from your operating system environment, which means that you are not going to get recoverability, but you will still have concurrency control between T-SQL access and Win32 access and between the two. The statement is very easy. You create a table as a file table and give it a name. And that will be giving you both the T-SQL experience as a table as well as the experience as a folder in Win32. The files and directories are being managed by a table with fixed schema. The data will be stored inside a file stream column. And each row represents basically a file or a document. One important aspect is that the file table is going to be supported by our new high availability support with always on. The file and directory hierarchy is exposed through a Windows share, where we have the normal Win32 API access supported for the document. So you can do drag and drop, as you have seen in the demo. Or you can use your standard Win32 application to open the documents inside the database itself. So now let's switch and look at what we are doing in terms of improving your experience with actually looking into the data of those documents and making sense out of it. In terms of our full text search support, we invested in 3 specific areas. The first one is we are improving performance and scale. So that means that we are now able to scale up to 350 documents for storage and search. We are working on improving the full text search query performance by a factor of 7 to 10 faster than in SQL Server 2008. And for the corpus that we are using for our internal testing, our goal that we set ourselves was to have a worst-case query response time of less than 3 seconds. The new functionality that we are adding is that we are adding the ability to do property search, so that you can search across your documents properties instead of just the whole document all at once, and that we give you the ability to customize the distance in your near predicate in full text search. We are also adding a new capability in search, which gives you the ability to find documents that are similar to other documents, which is, I think, an exciting innovation in search that gives us the ability to reason about the context of the documents and find things that are similar to each other. And I will show you a demo right now. Let me now show you what we have done on the full text side and semantic search side. Remember the file table that we had? And we created a full text index on it, like we would create any other full text index. But there were two new things that we are showing you here. One is that we are turning statistical semantics on. And the second thing is that we have a search property list that we are now registering with the full text index so that we can search just on the properties themselves. The properties that we created were 3 properties, the title, author, and tags. And you may notice these GUIDs here, which are the standard GUIDs for document properties that you can find on MSCDN or TechNet. So let me show you now first the search for properties. So in this case, what I do is I search the document where the title of the document contains data or SQL. So let's run this query quickly. And you will notice that I have about 60 documents that contain either data or SQL in the title. Now, just to show you, if I search for the document overall, not just in the title, I should be getting more documents back. And you will notice that I now get 96 documents back. So there are 36 documents that didn't have data or SQL in the title, but in the corpus itself. Now, I can also find documents where the 2 keywords, data and SQL, are close to each other, near to each other, with a specific distance of 5, and where the order is not important. So if I run this query, you will notice I'm getting 82 documents back where that data is near SQL, and the order is not important. If I change the order to be important, meaning that data has to become before SQL, you will notice that now the result set is reduced to 68 documents. So now let's show you the most exciting new capabilities that we have added with semantic search. So the documents now have been indexed such that I now know what are the semantically important key phrases inside the document. Note that this is done by doing some language analysis and looking at frequency of terms, etc. And it gives us the ability to understand what are the terms that the documents are being what are the documents about. That information is exposed by having some table-valued functions that we are providing, such as the semantic key phrase table that I'm showing you here. So this basically gives us the key phrases of all the documents that we have stored and indexed. It's normally keeping the top 100. And as you can see, for example, the document inside SQL Azure contains the key phrase Azure with a score of 1. And you will notice that I ordered them by score. And you will notice that these key phrases are basically really about what we have here. So for example, here we have HA with SQL Server 2008. And it has a key phrase mirroring that is definitely relevant for high availability in SQL Server 2008. Now, I can look at specific key phrases for documents using the semantic key phrase table and providing a document ID as an argument. So let me run this query here for the document called HA with SQL Server 2008. You will notice that I have 100 key phrases, and the key phrases that appear are SQL, high availability, failover, database, MSDN, server, etc. And you will notice that they all have a very high score. So now I can find out what are some of the other documents that are similar to this document by looking at the semantic similarity table. So I again use the document ID for the HA with SQL Server 2008 document. And you will notice that the highest ranking related document is HA with SQL Server 2008 R2. Probably our marketing department just replaced 2008 with 2008 R2 and did a few updates. So it basically has now the same content and talks about the same things. But you will also notice that other documents, such as, for example, Why Not Oracle Rec, are also related to this white paper with a slightly lower score here. Since I would like to understand now why are they being considered related, I can look up the relatedness and the reasons, keywords, why they are related in the semantic similarity details table. So I use both documents here. I run the query. And I see that they are related because they are talking about SQL, failover, high availability, etc. So it looks like that these documents might really be related to each other. Now let's head back to the slides and summarize what we have seen. Now let's recap what we have seen during the demo. You have an input inside your file table, inside the file stream column, that contains a variety of different documents, in our case primarily Office Word documents that are being put into the table. We are then creating a full text index with the semantic search enabled that is going through those documents and both extracts our standard full text keyword index and, in addition, analyzes the key phrases inside the document together with the language models that are installed inside the database to identify which ones of these key phrases are actually important and are considered to be representative of the content of the document. I would like to stress again that we are not doing that with ontologies that are domain-specific. Instead, we are actually only using generic language models to identify what are the phrases that are important for the context by means of occurrence, by the way that they're placed in the document, etc. And then we are also calculating a scoring function between the documents within the same column, within the same index, to figure out how related they are to each other. And as you have seen during the presentation, if a document is very close to another document, then you normally get a high similarity, while if the documents are only speaking across some key phrases, but otherwise are fairly dissimilar, then the score will be lower. To conclude the presentation, let me give you my key takeaways for you. First, SQL Server 2012's unstructured data support is giving you the ability to target non-traditional database workloads that you will be experiencing more and more in the context of your enterprise. For me, the amount of relational capabilities, including the rich unstructured data support that I've shown you, is a key strategy to help you build complex data applications that go beyond the relational data. Just to give you a little bit more detail on this topic, we have white papers on our SQL Server launch site. There's a Channel 9 data-bound episode that is covering semantic search in more detail. The demo that is being used in the Channel 9 presentation can be downloaded from Coplex. And there are more data sets and demo scripts that you can download and use yourself with SQL Server 2012. You can also reach out to me either on Twitter or via my blog. The address is here. Thank you very much and for your attention.